Hi everyone, I'm having a go at this because I had a bit of a try with my daughter who's a year 7 and it didn't quite work so well. So here we go. Algebraic fractions can be solved using the balancing method, but you need to take care. A simple rule of thumb to know what to do in what order is to use reverse BIM-DAS order. This requires knowing that there's an implied bracket around the numerator and denominator of any fraction, and that where a bracketed expression is being eliminated, it's usually best to treat it as a term. So let's illustrate what all that means. That's a good summary, but it's not really a teachable point when it's written like that. So here's a case. We've got 2x plus 3 equals 6. 6 plus 3 on 5 equals 6, and we want to find out what value will make that statement true. What value of x? Now, typically 2x plus 3 equals 6, if it was like that and there was no divided by 5 going on, we would just say subtract 3 from both sides. That's where the addition and subtraction is. So let's try that. And that would give us this line of reasoning here. Now, we wouldn't be able to go 3 take 3 because this is actually 3/5. So we're going to have to convert this to fifths first. So to do that, we're going to multiply by 5 on 5. And now we've got 2x plus 3 on 5, take 3 on 5. The denominators are the same, so we can subtract the numerators as per arithmetic. And lo and behold, if we do all of that, we end up with eliminating the 3 as we desired. But what if we didn't choose the 3 to be eliminated first? What if we said there was a bracket around this expression which would push the order that we do it into it, that we rearrange it back, and we do something else first? So what I'm going to suggest is, because of that bracket, BIM-DAS order says to do that last. We've got no other addition and subtraction, so we're going to have to do multiplication and division, which promotes this 5 to being the first thing that we rearrange. And that's what we're going to do here. So we multiplied both sides by 5. There's the multiplying both sides by 5. Then we broke this bracket up into 5 on 5 and 2x plus 3 on 1. The 5 on 5 becomes 1, the 5's eliminated, and we end up at this line of reasoning here, because 2x plus 3 on 1 is just 2x plus 3. We've simplified the 6 times 5 and made it 30. Now we subtract 3 from both sides. That eliminates the 3, then divide both sides by 2, and we end up with 27 on 2. Now if I take out all the words and just do it as algebraic operations, eliminate the 5 by multiplying both sides by 5, I get to this line of reasoning. Eliminate the 3 by subtracting 3 from both sides, I get to this line of reasoning. Eliminate the 2 by dividing both sides by 2, I get to this line of reasoning. So rather than doing all of this, which is quite complicated, I end up doing 3 operations, which are quite simple. And simplicity is what we're aiming for, both for the marker and for the doer. So here's a second case. This one's much more complicated than you expect in year 7, but if a year 7 does get this idea, they can quite simply do what I'm doing here. So we have an expression. We would say subtract 4 from both sides, and that will successfully eliminate the 4. So eliminate the 4 constant, subtract 4 from both sides. Now the next step, because we've got a bracket here and a bracket here and a bracket here and a bracket here, and these two things are being divided, we're going to eliminate the divisor first. So we're going to multiply both sides by x minus 5. The x minus 5s will cancel, and we'll have 8 times x minus 5 on this side. I think I illustrated it here. There's x minus 5 multiplying both sides. Here is swapping these two over, and then x minus 5 on x minus 5 is cancelled out, and we're left with this. Anything divided by 1 is itself, and we get to this line of reasoning here. Now, typically you won't do all of this. You'll just go multiply both sides by x minus 5, go to this line, because you know what's going on. Then multiply out both brackets. You end up with this term here, with this expression, this equation here. Collect the x's on one side and collect the constants on the other side. You'll end up with an expression like this. Divide both sides by 4. You'll end up with an expression like this. Simplify the left-hand side. You'll end up with this expression, and then swap the sides. You'll end up with that one. All quite simple, all quite straightforward, but it requires knowing this. If this doesn't make sense to you at some point, then this becomes more difficult than it needs to be. So we've done a difficult case. Let's do another one. Again, we've got this 4 here. We're going to eliminate that first. Once that's eliminated, we end up with this expression on the right hand side. Before we multiply the 5, it's probably best to reduce the number of terms we have to multiply by. So simplify the right hand side of the equation. Now multiply both sides by 5. Expand this. Collect all the variables on one side and all the constants on the other. That's what we did to this step. Divide both sides by 9. We get to this step and then simplify, because the highest common denominator of 12 and 9 is 3, and we end up with 4 and 3. Now, what I'm trying to demonstrate here is that as your skill improves, you can see where the steps can be skipped. You just don't want to be skipping them too soon. So once you're thinking in the way that I'm describing, then you can start to skip steps. Now, you don't have to do it in reverse beam desk order, and not all teachers will teach it that way. But let's look at a case where we don't do it in reverse beam desk order. We don't look at solving as unwinding an equation. So 2x plus 1 equals 5. Normally we would do the plus 1, that's reverse beam desk order. We're going to do the 2 first. So divide both sides by 2, no problem. Split the fraction. 2 divided by 2 becomes 1. We have x. X plus a half equals 5 on 2. Subtract a half from both sides. 5 halves take 1 half is 4 halves. 4 halves simplifies down to 2. Quite straightforward. Now let's look at it using reverse beam desk order. 2x plus 1 equals 5. Subtract 1 from both sides. 2x equals 4. Divide both sides by 2. X equals 2. Finished. Which one has more operations? Which one is more complicated? And that's generally how it plays out in nearly all cases. Sometimes not, especially when distributive law comes in, but generally so. So we're going to go through a whole heap of solving practice and go through some of the things where you might make a mistake, and go from there. The second one, where we're dividing by a fraction, we'll probably do a little bit more. I'll probably put a card up here later to say click here and do some more practice on dividing by fractions, but that's for another day. So 7x plus 2 equals minus 19. Subtract 2 from both sides. Divide both sides by 7. That gets you to x equals minus 3. 3x minus a third equals 5. Add thirds to both sides. Make the right hand side into a improper fraction. Simplify. Divide both sides by 3. Dividing by 3 is the same as multiplying by a third. That will get you easily to 16 on 9. Otherwise, you can think about it as 16 on 3, each part divided into 3 more parts will give you 9 parts, so it'll be 16 on 9. Either logic's fine, just whichever one you're more comfortable with. 5x take 4 equals 21. Add 4 to both sides. Divide both sides by 5. You get to x equals 5. Here's a nifty trick. Negative 7x equals 21. Divide by negative 7 rather than dividing by 7, multiplying by negative 1. Divide by negative 7, you'll end up with negative 3. This question here, 18 takes 7x equals minus 3. Subtract 18 from both sides. Divide both sides by negative 7. Since you'll end up with a negative numerator and a negative denominator, negative divided by negative becomes positive. 3x plus 4 equals 21. Divide both sides by 3 to eliminate the 3 in front of the bracket, which will give you x plus 4 equals 7. Subtract 4 from both sides, you end up with x equals 3. 2x on 3 take 3x on 5 equals 8. You can't subtract unless you've got a common denominator. Make a common denominator of 15. Multiply the first one by 5 on 5 and the second by 3 on 3. That will leave you with 10x take 9x on 15 equals 8. 10x take 9x is x, so that's where the x on 15 comes from. Multiply both sides by 15. 8 times 15 is 8 times 10 is 80, plus 5 times 8 is 40, is 120. Next one, 3x take 9 equals 5x take 3. Add, what are they doing here? Subtracting 3 from both sides. Add 3 to both sides. Swap the sides. Divide by 2. You'll end up with negative 3. Here's a case where rather than dividing out the multiplication, we're just going to multiply out the brackets first. So you end up with 3x take 9 equals 8x plus 4. And then subtract 3x from both sides. Subtract 4 from both sides, divide by 5. 3x on 2 take 10 equals 1 on 2. Add 10 to both sides, and then multiply everything by 2 to eliminate the 2. You end up with 3x equals 21. Divide both sides by 3. You get x equals 7. There's a couple of different ways you can do this one. That's just one way. I don't even know if that's the best way. X on 2 take x on 3 equals 8. Common denominator, the lowest common denominator, lowest common multiple would be 6. Multiply the first term by 3 on 3, the second term by 2 on 2. You'll end up with 3x take 2x on 6 equals 8, which will simplify to x on 8. Multiply both sides by 6, you will get x equals 48. In this case, first multiply out the third term, then collect terms on the left-hand side and right-hand side, then collect all the x's on the left-hand side, collect all the constants on the right-hand side, divide by 7. In this case, multiply out all of the brackets, collect all the terms on the left-hand side, collect all the terms on the right-hand side. Probably easiest to add 3x to both sides. That's what happened here. Eliminate the constant on the right-hand side. That will give you 49. Divide both sides by 5, you end up with 49 on 5. Here's that nifty trick I showed you earlier. Multiply both sides by y on 7. The y on 7s will cancel out on this side. You'll end up with y on 7 on this side. Multiply both sides by 5, which is what I did here. Multiply out each bracket. Collect the like terms on each side. In this case, I think we're collecting the y's first and then collecting the constant second. Divide both sides by 8. Similar here, multiply both sides by 2x on 3. That will eliminate this one, make it into the denominator. Multiply both sides by 2. That will eliminate the denominator here. Then multiply out the brackets, collect the terms on each side, and we'll collect the variable on one side, the constant on the other side. Divide, you end up with x equals 5 on 12. Now here I start to skip steps. You would have noticed that that just goes up here, that just goes up there. You end up with this expression here. Multiply that out, collect the terms, simplify, end up with x equals 31 on 2. Here's a fraction. I don't like working with fractions. Here's a decimals. I don't like working with decimals, so convert them to fractions. Be careful that this quarter applies to this term and this half only applies to this one, not this one, because there's no bracket here. And don't fall into the trap that I did the last time I did this video. I had to re-record the whole thing. So here's what I've did. It's a bit of a trick. I've multiplied everything by 4. So that will become 2. That will become 1, and that will become 36, and that's what's happened here. That allows me to subtract 2y from both sides, which gets me to here, add 3 to both sides, which gets me to here, divide both sides by 2, and I'm done. So if you can follow what I've just said and be able to do that yourself, you are well on your way to having a very solid tool to use for just about all branches of mathematics. Hopefully that's helped, and I will speak to you all soon. Thank you.